Hello, my name is Abdullah. My student ID is 2016-00306. This video is recorded to demonstrate two different solutions which help in solving issues related to two different domains. In addition, an implementation of a hacking tutorial will be evaluated and discussed. Let's talk about the first idea. The Internet of Things is a broad title, and many topics come under this title. The automated cars are one of these topics. An applicable critical vulnerability to various automobile networks that include CAN bus network will be unveiled, where a denial of service attack is applicable. It is also called the bus off attack. This attack disconnects or shut down the ECUs by exploiting the error handling technology of the network. A security monitoring system is proposed as a solution for the problem. This system will authenticate between each transmission node and the monitoring node. As a result, only the authenticated CAN message will be processed. Several technologies need to be provided to equip the security monitoring system in the automobile efficiently, such as CAN controller, which allows the monitor node to understand the function of the CAN protocol, and cycle redundancy check, which is used to detect the errors in the data transfer because there is the possibility that the numerical values of the output from various data being the same. Then, the hash function. It is required to compress a string to a specific length of data. Next, monotonic counter. It is needed to protect the system from reply attacks. The sequence diagram will represent and describe the authentication process between the monitoring node and the transmission node. In the beginning, a random seed has been transmitted from the monitoring node to the transmission node. Then, both nodes will use the hash function to calculate and generate the digest. An authentication request will be sent from the monitoring node to the transmission node by transmitting part of the digest. After that, the transmission node will compare its calculated digest with part of the received digest from the monitoring node. If both digests are equal, the transmission node will transmit the subsequent digest to the monitoring node. If the digits are not equal, it will consider as an authentication error and the message will be destroyed. After that, the monitoring node will conduct the authentication by comparing the calculated digits with part of the received digest from the transmission node. If the authentication has been conducted, the message will be considered as authenticated message and it will be allowed to complete its process. However, if the authentication is not conducted, the message will be destroyed. Second idea. Log4j is a highly used Java logging framework that is adaptable, reliable, and fast, published under Apache Software License. Any systems and services that use Apache Log4j between version 2 and 2.15 are vulnerable, include Microsoft Azure, Amazon, Fortnite, Minecraft, and iCloud, etc., which means this issue is related to personal security. The Log4j vulnerability is a new vulnerability that can be used to get full access to the target host. Due to the bug, online systems inherited from Java are exposed to zero-day attack. A Microsoft 365 Defender was proposed as a solution for Log4j vulnerability in case of the Log4j cannot be updated to version 2.16. Microsoft 365 Defender dynamically perform investigation and detection across numerous units such as applications, endpoints, and emails to hunt and prevent any exploitation of the Log4j vulnerability. There are several technologies that have been used to implement the Microsoft 365 Defender and make it able to detect and prevent Log4j vulnerability. Endpoint with Defender is a unified endpoint technology for preventative protection, post-breach detection, automated investigation, and response. HTML5 web browser is introduced a slew of new capabilities to make website development easier and improve user experience. Many improvements to web forms are among such features. The last one, Azure Active Directory. It's cloud technology that accesses management Microsoft cloud-based identity service that support the employees to sign in and access the resources, including external and internal resources. The next diagram will represent and describe some of the investigation and detection processes of Microsoft 365 Defender across numerous units. The first event, Microsoft Defender for Endpoint and Microsoft Defender for Cloud, examine HTTP headers for exploits attempts. The second event, Microsoft Defender for Endpoint and for Identity, scan LDAP queries network packets for exploits. The third event, Microsoft Defender for Office 365, investigate email containing payload string in subject, header, body, or sender fields. The fourth event, Microsoft Defender for Cloud Apps, detect payload located in application or device name. The fifth event is Microsoft Defender for Endpoint, detect exploits over network traffic. The sixth event, Microsoft Defender for Endpoint, spot vulnerable Log4j libraries. The seventh event is Microsoft Threat Experts, dedicated experts monitor network to detect exploit attempt and notify clients. The next event, which is the eighth one, Microsoft Defender for Endpoint produce detailed analysis and regards of possible threat activity across the network. The ninth event, Microsoft Defender Antivirus detect post and pre-exploit behavior. The last one, Microsoft Defender for Endpoint detect exploit based on processes, endpoint, event, and behavior. In our tutorial, we will use one virtual machine, which is Kali Linux. In addition, an HTTP server on port 8000 and an LDP server on port 9001 will be created and set up, as they are essential to form a session with the target host. The target host will be a vulnerable web app running on localhost 8080. The online tool demonstrated below will help in generating a payload exploiting Log4j vulnerability. After running the tool, a GNDI payload will be produced. After that, copy the created GNDI payload and paste it in the target vulnerable attribute. Then, the tool produces overall feedback outlining target vulnerabilities and risks that may occur if the given vulnerability is not resolved. Initiating the attack. First, clone the GitHub repository which contains the required script. After that, install Colorama and Argopras packages. By run requirements.txt file. These modules will create a user-friendly terminal. Then install the JDK version that includes the Log4j vulnerability. Then move it to the proper location. After that, start a netcat listener to accept reverse shell connection. Then, the script below will generate the payload and set up the LDAP and HTTP server. After that, install a Docker file that includes the vulnerable web app. After that, build a Docker file with the vulnerable web app by using the build command. Then, create the Docker file by use the run command to run the web app on the local host in port 8080. And here we can see the web app. It runs on localhost port 8080 successfully. Then copy the payload which has been generated previously and paste it in the vulnerable target parameter to gain the access. At the end, the result of the tutorial will be displayed to confirm that the attack has been implemented correctly and the root access has been gained. As shown in the picture, the session has been initiated and the LDAP reference is sent to web server on port 8000. Also, root access has been guaranteed, and now it is possible to initiate reconnaissance attacks, manipulate system attributes, run malware, and much more. And thank you for listening to my presentation. I'll be more than glad to answer your questions if you have any.